Greetings, Professor Pan here. This video discusses calibration. According to the USA's National Institute of Standard and Technology, calibration is the comparison of two instruments or measuring devices, one of which is a standard of known accuracy, to detect, correlate, or eliminate by adjusting any discrepancy in accuracy of the instrument or measuring device being compared with the standard. Calibration isn't to be confused with the instrument verification, which is defined as confirmation by examination of evidence that a measuring equipment fulfills specified requirements. The specified requirements are usually under certain working conditions, throughout the whole period of use, and the results should be within given permissible error. Calibration. Calibration consists of comparing the output of the instrument or sensor under test against the output of an instrument of known accuracy when the same input is applied to both instruments. This procedure is carried out for a range of inputs, covering the whole measurement range of the instrument or sensor. This is because calibration ensures that the measuring accuracy of all instruments and sensors used in a measurement system is known over the whole measurement range, provided that the calibrated instruments and sensors are used in an environmental conditions that are the same as those under which they were calibrated. Calibration instruments. Instruments used as a standard in calibration procedures are usually chosen to be of greater inherent accuracy than the process instruments that they are used to calibrate. Because such instruments are only used for calibration purposes, greater accuracy can be often achieved by specifying a type of instrument that would be unsuited for normal process measurements. For instance, ruggedness is not a requirement, and freedom from this constraint opens up a much wider range of possible instruments. In practice, highly accurate, null-type instruments are very commonly used for calibration duties, because the need for a human operator is not a problem in these circumstances. Frequency of calibration. Instrument calibration has to be repeated at prescribed intervals because the characteristics of any instrument change over a period of time. Changes in instrument characteristics are brought about by such factors as mechanical wear, the effects of dirt, dust, fumes, chemicals, and temperature changes in the operating environment. To a great extent, the magnitude of the drift and characteristics depend on the amount of use an instrument receives, and hence on the amount of wear and length of time that it is subjected to the operating environment. However, some drift also occurs even in storage as a result of aging effects and components within the instrument. The type of instrument, its frequency of use, and the prevailing environmental conditions all strongly influence the calibration frequency necessary, and because so many factors are involved, it is difficult or even impossible to determine the required frequency of instrument recalibration from theoretical consideration. Once the maximum permissible measurement error has been defined, knowledge of the rate at which the characteristics of an instrument change allows the time interval to be calculated that represents the moment in time when an instrument will have reached the bounds of its acceptable performance level. Obviously, the instrument must be recalibrated either at this time or even earlier. This measurement error level that an instrument reaches just before recalibration is called the error bound. The error bound must be quoted in the documented specifications for the instrument. Documentations. Whatever system and frequency of calibration is established, it is important to review this from time to time to ensure that the system remains effective and efficient. It may happen that a cheaper but equally effective method of calibration becomes available with the passage of time, and such an alternative system must clearly be adopted in the interest of cost efficiency. Calibration interval is still appropriate. Records of the calibration history of the instrument will be the primary basis on which this review is made. It may happen that an instrument starts to go out of calibration more quickly after a period of time, either because of aging factors within the instrument or because of changes in the operating environment. The conditions or mode of usage of the instrument may also be subject to change, as the environmental and usage conditions of an instrument may change beneficially as well as adversely. There is a possibility that the recommended calibration interval may decrease as well as increase. Control of calibration environment. Calibration instrument. Any instrument that is used as a standard in calibration procedures must be kept solely for calibration duties and must never be used for other purposes. Most particularly, it must not be regarded as a spare instrument that can be used for process measurements if the instrument normally used for that purpose breaks down. Proper provision for process instrument failures must be made by keeping a spare set of process instruments. Calibration area or room. To ensure that these conditions are met, the calibration function must be managed in a professional manner. This will normally mean setting aside a particular place within the instrumentation department of a company where all calibration operations take place and where all instruments used for calibration are kept safe. If possible, this should take the form of a separate room rather than a sectioned off area in a room used for other purposes. This will enable better environmental control to be applied in the calibration area and will also offer better protection against unauthorized handling or use of the calibration instruments. Calibration personnel. Calibration procedures that relate in any way to measurements that are used for quality control functions are controlled by the international standard or ISO 9000. One of the clauses in ISO 9000 requires that all persons using calibration equipment must be adequately trained. The manager in charge of the calibration function is clearly responsible for ensuring that this condition is met. Training must be adequate and targeted at the particular needs of the calibration systems involved. People must understand what they need to know and especially why they must have this information. Successful completion of training courses should be marked by the award of qualification certificates. These attest to the proficiency of personnel involved in calibration duties and are a convenient way of demonstrating that the ISO 9000 training requirement has been satisfied. Calibration chain. Working standard instruments. The calibration facilities provided within the instrumentation department of a company provide the first link in the calibration chain. Instruments used for calibration at this level are known as working standards. As such, working standard instruments are kept by the instrumentation department of a company solely for calibration duties and for no other purpose, so that it can be assumed that they will maintain their accuracy over a reasonable period of time because use-related deterioration in accuracy is largely eliminated. Secondary reference standard. However, over a long term, the characteristics of even such standard instruments will drift, mainly due to aging effects in components within them. Therefore, over this longer term, a program must be instituted for calibrating working standard instruments at appropriate intervals of time against instruments of yet higher accuracy. The instrument used for calibrating working standard instruments is known as a secondary reference standard. This implies that it will be an expensive instrument to buy. It also requires that the environmental conditions in which it is used must be carefully controlled in respect of ambient temperature, humidity, and all other factors. Primary standard. Primary reference standards describe the highest level of accuracy that is achievable in the measurement of any particular physical quantity. All items of equipment used in standard laboratories as secondary reference standards have to be calibrated themselves against primary reference standards at appropriate intervals of time. This procedure is acknowledged by the issue of a calibration certificate. That's it for calibration. The contents of this video are from the fourth chapter of the book, Measurement and Instrumentation, by Morris and Langari. I highly suggest that you check that out for more information about the subject.